computing the sample correlation coefficient and the coefficients of the linear regression line. So here we got this problem. The candidate is a popular model of sport utility vehicle, known for its relatively high resale value. The bivariate data given below were taken from a sample of 15 cadets, each bought new 2 years ago and each sold used within the past month. For each cadet in the sample, we have listed both the mileage, X in thousands of miles, that the cadet had on its odometer at the time it was sold used, and the price, Y in thousands of dollars, at which the cadet was sold used. These data are shown graphically in the scatter plot in figure 1. So we have X is the mileage and Y is the selling price, both in thousands of miles and thousands of dollars. They also give us the value of the sample correlation coefficient. R for this data is approximately negative 0.792. So they give us the R, which is nice. Okay, so it's negative. That goes along with our slope being negative right here. So this guy's a downward track from left to right. So we know our slope is going to be negative. So I'm guessing we have to find, yes, the slope right here and the y-intercept. So when we find the slope, there's a good check right there to see. So since our graph goes down, we know we're going to have a negative R and a negative slope. So remember the R, the correlation coefficient, the closer it gets to 1 or negative 1, the stronger it gets. The closer it gets to 0, it gets weaker. So since this is like negative 0.8, that is very close to negative 1. So this is a very strong negative correlation. All right, so let's go find what we need to find here. So we have the slope. First thing we need to do is find the slope. What's the value of the slope of the least squares regression line? So the slope is, these are just, pull up the formulas right here. So I've got them already over here for us. So the slope has to do with this. So this is like y equals mx plus b. They use b sub 0 and b1, b naught and b1 for their m and their x. So remember, m is my slope, b is my y-intercept, and then x and y are actually any point on the line. So everything is the same here when we go to this formula. All they did was kind of mix it up, and they put the b over here for us and moved it to the left, but it is still the same picture that we have here. Let me get it back here. So this right here is what that is. So this is my y-intercept. So b sub 0 is my y-intercept. Okay, this is my starting point. So if we were graphing this, we would actually just start where the y-intercept is. Okay, so remember when you're talking about y-intercept, to find the y-intercept algebraically, what we actually do is we make x be 0. So that'll come in handy when we go to interpreting. B1 is our slope. Okay, so that's rise over run. So you go up if it's positive, and then to the right. And if it's negative, you go down and then to the right. Okay, so we don't have to actually graph these, but it's nice to know that when we're talking about these, when we're talking about interpreting these. All right, so our formula to do these. So what we need to find is the B1. Our B1 is our slope. So we're going to use this formula right here to find our slope. This calculator, hopefully it does a lot for us. Let's go to the calculator. So some of the problems will give you x and y multiplied out. That's the first thing we got to find, is the sum of x times y. So we got to do each x times each y and then add them up. You can use this formula if you'd like. This one just is a little bit longer. This is kind of the shortcut of this version. So I'm going to use this one over here and make this go a little faster. All right, so we want to find each x times each y. So you can sit here and you can do 26 times 26.1, write that number down. 23.5 times 27.9, write that number down. 23.9 times 29.7, write that number down. So each row times each other and then add all those up. That takes a lot. So I'm going to send it to Excel actually. And I'm going to have it do it for us in here. Actually, it sent it to numbers. So let me put it in Excel. So now that I've sent it to Excel, I'm going to kind of cheat and do this quicker. So the way you do it in Excel is click just over on a different cell to kind of start this. I'm going to press equal to start an equation. And then if I click on the first cell and then use the asterisk, which is Shift 8, and then click on the other cell, that's doing A1 times B1, which is 26 times 26.1, and press enter, and that gives me the number. Now this little square right here, if I just drag this down, it'll actually do all of those for me. And since we're right here and we have to add all those up, it's easier just to go ahead and use Excel to do that for us too. So I'm going to do equal. Again, just pick any cell that's different from those. I'm going to type sum, because that's what we're going to do. We're summing these up, and then all you got to do is highlight them, all the numbers you want to add up, and press enter again, and you get your number. So here's our first number, 1,948.06. All right, so I'm going to write that here. Just kind of keep track of here. Sum of x times y is equal to this number. I'm going to delete this so we can get it all on one page. All right, so we got the first number here. Now what's the next thing we need? We need n. So our n is how many total numbers there are. So how many total cars do we talk about here? It probably tells us in the problem, so we don't have to count. I'm looking. 15, there it is, 15 cadets. So 15 is our n. All right, the next thing is x bar and y bar. So this is the average of x and the average of y. So the Alex calculator does this nice for us because we have this x bar button right here, which is the average of x. So all we have to do is highlight the x column, just the x column, to get it in the calculator. And I'm going to hit the average button, so that finds the average for us. So our x bar is 25.71333. All right, what's next? So now we got to do the y bar. So same thing, we are going to highlight the y column. Now let me clear this, make sure I got everything out of this calculator. We're going to highlight the y column, and then again we're going to hit x bar, but all that's doing is finding the average. It doesn't matter if that's an x and we're doing y, it's finding the average of the y. So we highlighted the y's, we hit this average button, so now our y bar is 28.84. All right, so we've got the numerator. That's all the numerator stuff. So now we need to figure out the denominator. So the first thing in the denominator is n minus 1. So that's 15 minus 14. So remember, n is how many total cars there are. So 15 minus 1 is 14. So the next thing is n minus 1. So remember, n is how many total number of cars that you're looking at. So we have 15, so we're just doing 15 minus 1, which is 14. And the last thing is the s sub x squared. Okay, so the s is our standard deviation. Okay, so our s is our standard deviation for your x's. So we're just looking at the x's. So we're going to, our calculator actually has a button right here for that. That's going to find us a standard deviation. So I'm going to highlight the x's, hit the s button. That gives us the standard deviation. But since we want to do it squared anyways, we might as well square this while we're here. So let's square it. And now our number is 29.06695.238. All right. Now we have all the numbers that we need from this formula. So let's go do this formula. So the first thing we do is the sum of x times y, which was 1948.06, minus our n, which is 15, times x bar, 25.71333, times our y bar, which was 28.84. I'm going to press enter because that's my numerator. So there's my numerator number. And I'm going to divide it by 14, which is n minus 1, times the s of x squared, or s sub x squared. 14 times 29.066952398. And remember, I said we should get a negative number because our slope, our graph is negative, our r is negative, so our slope should be negative. So my slope should be negative 0.4313. How many it says go at least 2 decimal places, so we can just do 43, right? All right, so that is the hard part of this one. Now we have to find the y-intercept. What's the value of the y-intercept? They actually give us a formula down here to find the y-intercept. Okay, so we know some of this information. We know what y bar is. We know we're trying to find b naught, which is b0. Y bar is 28.84. Just looking right here above, I've got that information already. Yes. Our B1, which is what we just found. So that's what number's in the calculator. So we do minus a negative 0.4133 559. I'll hit store in the calculator so we can save that one for us. But be careful here. You have minus and negative. So if you were doing this by hand, you'd have to change that to plus. But we're going to do it in the calculator. It'll do it for us. So then we take it times x bar, which is 25.71333. Okay. All right, so let's do this in the calculator. So we stored the slope, so we don't have to type that in. So now we're going to put this in the calculator. So 28.84 minus the slope. So hit recall. Let's go ahead and delete this blank right here. Okay, it doesn't like that we put minus and negative right there. So let's go ahead and just change this to plus, because minus and negative becomes plus, times 25.71333, and we get 39.93. All right, so our equation, let's talk about what the equation means real quick before we leave. Y equals y equals B naught, which is 39.93, minus our slope. Okay, so there's kind of our y equals b sub 0 minus b sub 1 times x. So here's kind of what this means. So this is the average of all these points. So if I drew this or graphed this line, it would be right in the middle of all these. You can kind of see if I trace, like I should hit about 40 on the y-intercept because that's where my y-intercept is. So it'd be right in the middle of these. So this is the average. That's why they use y hat for this, because we're going to use this to predict what would happen. So if we have a used car and we know how many miles are on a used car, we can plug it into this equation and get how much we should probably sell it for. So we can use it to predict how much a car should sell for based on its mileage. All right, so what these numbers mean. So you start at the y-intercept. I said that's up here. Where you think about x being equal to 0. Okay, so if x is 0, your y-intercept is 39.93. That means if we have 0 miles, because x is mileage, if we have 0 miles on the car, we'd expect our used car to sell for almost $40,000. Okay, because remember, these are in thousands of dollars. So if 0 miles are on the car, we'd expect to sell for about $40,000. And what happens here is, since x is in thousands of miles, so for every, think rise over run for the slope, and we're going down because it's negative, so every 1,000 miles that we put on the car, it's actually going to lose about $4,300, take this times 1,000, $4,300 in price. That's not right. So it's actually going to lose, if you take this times 1,000, you would get, we can see, 0.43 times 1,000, because it's in thousands of dollars is what we're talking about. You're actually going to lose $430 for every 1,000 miles that you put on it. So every time x goes up by 1,000, or 1, every time x goes up by 1, that means we're putting 1,000 more miles on the car, and that would drop the price $430 for every 1,000 miles we put on there. Let's check it, make sure we got it right. We are correct. All right.